Hello, everyone, and welcome back from Dubai at COP27. We are at the Digital Innovation Pavilion, and I'm Domenico Vito. I'm here representing Hubs in Italia and Metabolism of Cities Living Lab. And together with me, there are some guests that are connected online. I will warm welcome Dr. Fernandez, Marco, and Tim. Thank you very much for being with us. So this event that we launched in this morning of Dubai is related to another digital innovation that's very important. Actually, climate change is a very, very powerful threat, but we have also another environmental threat that is the safeguard of marine ecosystem. And in this digital innovation, data, and also digital twins are a new technology that can help on giving a framework and models in order to manage the problem of plastic pollution and marine ecosystem preservation. Moreover, data are not ended in just these technologies. Through data, we can also engage communities, engage citizens. And we at Metabolism of Cities Living Lab, we are properly developed like a protocol, a framework to engage citizens in data collection. But I will not say nothing now. I will give the floor to Dr. Fernandez to introduce the session. So thank you very much, Dr. Fernandez, for being with us again. A pleasure to see you. So the floor is yours to your first speech. Thank you very much.
Thank you again for hosting us. I think it's excellent. I apologize for not being in Dubai, but I'm glad that our colleague, Dr. Domenico Vito, is able to be there in person. So I will now share my screen, share a little bit of the work that we're doing at Metabolism of Cities Living Lab that we have done more recently, but as well as in the previous years. All right, and let me just share my screen here. All right. Okay, here we go. So this session is called Digital Ocean and Citizen Science Approaches. I will discuss a bit more of our activities from trash to treasure that we have done.
Just one second, Dr. Fernandez. Yes. We cannot see your slide, so eventually you have to change the window.
Okay, let me just share again one more time. How about now?
Just one second. That is starting. No, we cannot.
Can you see my slide?
Now, yes. Now we saw the presentation. If you go into presentation mode, we will see. Okay.
Okay, great. Thank you for letting me know. Again, so we will be sharing.
Just one second. If you can click on hide on when you have like the screen sharing StreamYard. You can click hide so we cannot see the bar. Perfect. Okay, thank you very much. Please.
Okay, thank you. Okay, all right. So I just want to share some of the activities that we have done in the past concerning our from trash to treasure activities. So again, I'm Dr. Gabriela Fernandez. I'm a professor at San Diego State University in the Department of Geography. I work with students in the Master of Science in Big Data Analytics. I'm also a member of the UN Major Group for Children and Youth, where we work on microplastics and marine litter. I'm the director of the Metabolism of Cities Living Lab, and I work on several different. I have several different interests from vulnerable communities, big data analytics, the topic of urban metabolism, spatial planning, as well as marine litter. So what we do in the lab is we try to work on projects that are data-oriented solutions. So we work on advocating for the UN Sustainable Development Goals, working closely with different partnerships from universities, cities, individuals, and organizations. We aim to work closely with vulnerable communities, if that is children, elderly, people with disabilities, ethnic minorities as well. We have developed several different activities and projects with students, developed seminars, conferences around the world, attended international events such as COPE, as well as developing several citizen science activities. One of our activities that we will be sharing today is our beach cleanup that we have done in the past with several different nonprofit organizations. I'll skip over our video just to save some time. And in the past, we have worked closely with a nonprofit organization called Casa Congo, which is located in Nicaragua, in El Astillero. We developed a step-by-step toolkit in order to help several different organizations on how to properly collect waste and develop their own beach cleanup. We have developed the material in both English as well as in Spanish. And here you can see some of our 10-step toolkit that we have developed for our From Trash to Treasure educational campaign. Here's a little bit more of the work that we've done, where we teamed up with Casa Congo as well as Race for Oceans through an Unleash activity. We presented these different activities at the United Nations Decade of Ocean Scientists for Sustainable Development. In this particular activity, we wanted to advocate for the SDG goals. We advocated for SDG goal number 4, 14, and 12. The idea was to have an event where we had several different topics related to data and monitoring, education and children, art and humanities, technology, industry, tourism, and management. Where we had a competition, a type of hackathon, and we invited students, professionals, organizations, nonprofits from all around the world in order to participate in this international event. The idea was to develop a virtual beach cleanup with Casa Congo in Nicaragua, particularly working closely with children in elementary schools. The event not only provided tools and resources on how to develop a beach cleanup, but also we had educational lectures to educate children on the different issues that are happening in our beaches in coastal areas as well, how tourism is affecting, let's say, current residents that are found in these areas, the different industries that are also found along these particular areas along the El Astillero in Nicaragua. Additionally, we had some fun activities where students were able to, let's say, do beach activities such as surfing. Here you can see a bit of our, let's say, activities that took place where the children separated the trash. We had several different teams, different quadrants that each team had to work closely with. And here are parts of few of our screenshots where children were educated on the different aspects of and issues that are happening along our coastal cities. Additionally, we interviewed several children. We asked them if they already knew about some of these issues that were found in El Astillero. A lot of them were familiar with what was happening, although we did come across some children that had no idea. So I think that it was quite interesting to also hear their perspectives and their points of view, and also if they're aware of what their current government is working on. Additionally, we wanted to stretch out this different protocol, and we work closely with the Poly Foundation, which is in Kenya. Again, we wanted to make sure that we tackle and localize the sustainable development goals by focusing on these 4 different SDG goals. We wanted to not only develop a beach cleanup in San Diego, particularly a city called the city of Imperial Beach, which is located along the U.S.-Mexico border, but we also wanted to develop this methodology that can also be applied in Kisumu, Kenya, which is a beach called Dunga Beach. The idea was to follow the same step-by-step beach cleanup protocol as we did in Nicaragua for Imperial Beach as well as Dunga Beach. In order to have a better understanding of what is happening in San Diego, here you can see the 10 different steps that I shared previously for Nicaragua. This is the team that we work closely with, Dr. Domenico Vito, Carol Maione, as well as Dr. Pauline Owiti from Kenya. The idea was to have a better understanding of what is the current situation along the U.S.-Mexico border in order to, let's say, capture that essence of the issues in Southern California. And here we visited several different areas along the border to have a better understanding what is happening in these areas. So here you can see a couple photos. We found some dead fish. We understood that there's a smell also that is found in some of these border, let's say, neighborhoods along the Imperial Beach border. And also lots of trash and waste that is found. Here is a project that was developed by a professor at USC. It was found at the Smugglers Gulch Canyon. And this device helps, let's say, local governments collect waste. And this is a photo of what was collected the day before, I believe it had rained. So this is quite interesting and quite shocking to see how much trash is accumulated along the U.S.-Mexico border. Additionally, we developed a beach cleanup where we work closely with several different students who participated, as well as students from the Prus School, which is a high school, which is a part of UCSD here in San Diego as well. We try to educate the children on how to properly collect trash, what exactly they should be looking for. Additionally, we had them fill out a document where every volunteer was able to have a better understanding of what item is collected based on several different types of categories, based on different transects that were identified in the Imperial Beach neighborhood. So here you can see a couple of photos. We wanted to understand where exactly they found the waste within, let's say, our case study area. Additionally, informing them on the topic of microplastics. So they were also collecting microplastic waste pieces, additionally to larger structures found in the beach. So here's photos of the event. Here are some of our students collecting, let's say, trash that was found. Different devices. So I will go through these different slides quickly because we do have quite a bit. Additionally, we asked some of our volunteers to share with us which SDG goals are more passionate about. A lot of our volunteers were from Southern California, so they were from different cities: City of Imperial Beach, City of Chula Vista, City Heights, City of San Diego. So we wanted to have a better understanding of if they were aware of the UN Sustainable Development Goals and why they were important to them, and which SDG goals were more important to them compared to others. So here you can see some of our volunteers that participated. Some of them were from the Prus School at UCSD. So here are some more. Here you can see some of the trash that was accumulated and collected. A lot of the participants were not only residents, but we also had some visitors from different countries as well participate in this activity. Okay, moving on. Okay. Additionally, we separated the different waste. We wanted to have a better understanding of what were these wastes that were found, in which categories, if we had more plastic, paper, metals, and so. So here you can see a bit of a sample of some of the materials that were found during this event. Okay, as we all expected, plastic is in fact the largest, let's say, category that was found during our beach event. So bottles, plastic wrapping, bottle caps, beach toys, plastic containers, straws, plastic cups. So here we also started to have a better understanding of what were some of these participants collecting. So the majority, again, were plastics, and some of our participants were between the ages of 25 to 35 as well. So here you can see a couple of the statistics. Additionally, we wanted to have a better understanding not only what exactly is happening during our beach cleanup, but we also wanted to have a better understanding of the perceptions and attitudes and behaviors in the city of Imperial Beach. So we asked several different questions. If they're local to Imperial Beach, or they live outside of San Diego, and how frequently do they visit the beach or swim in the ocean in Imperial Beach. If they've heard about any pollution in the Imperial Beach area, have they ever swam in the ocean near Imperial Beach? Have they ever noticed any distinctive smells in the ocean near Imperial Beach? Or have they become sick or heard of someone becoming sick after swimming in the ocean near Imperial Beach? And also, have they ever heard on the topic of microplastics? So here are a couple of our let's say, results. So here we can see that the majority of our let's say, answers, a lot of our participants were from the city of San Diego, and some of them were local, although some of them were from outside. Concerning how frequent do they visit the beach or swim in the ocean in Imperial Beach, many provided not so frequent. And if they've heard of any kind of pollution in Imperial Beach, the majority have heard of what is happening in Imperial Beach. If they've ever swim in the ocean near Imperial Beach, the majority here responded yes. And if they've ever noticed any kind of smell, the majority responded yes. And if they've ever become sick or heard of someone becoming sick after swimming, it was more of between yes and no. And if they've ever heard of the topic of microplastics, it was quite interesting. It was a between yes and no. So for us, it's quite interesting to find out it's not only about collecting waste along the coastal areas of neighborhoods, but also having a better understanding of people's perceptions, attitudes, and beliefs. Additionally, we did the same beach cleanup protocol in Dunga Beach in Kenya. So here you can see some of the different activities that took place during this day on May 7th of last year, as they also sorted the different materials. They worked with teams and different volunteers from different age groups in order to come up with this same type of protocol as we did for Imperial Beach, as well as El Astillero in Nicaragua. So here you can see some of the devices and waste that was collected. And why am I sharing this with you? So currently we have been, let's say, adding further data into our interactive dashboard. It's not only about collecting the different the data sets along these beach cleanups, but it's also about putting the data into interactive visualizations. Why is this important? This can allow us and help us identify, let's say, several different injustices that are happening along our cities. Additionally, we want to not only collect the data and develop interactive surveys, but also we want to identify these areas that are found within not only San Diego County, but also in different locations as well, through our Leave No One Behind dashboard that we're currently have been working on for the past. Here we can see, let's say, more on child poverty, right? And so here we can see the different pollution areas that are found within San Diego County as well. And this interactive dashboard is a way that we can also provide some analysis and recommendation to local governments. So here you can see the racial disparity in toxic air and how this can help us identify areas that need further beach cleanups. So currently we are working to expand our interactive dashboard as a way to incorporate further data. So if you are interested to work with us and develop a beach cleanup using the protocol that we have developed, please go ahead and reach out to us. But the idea is to make sure that we reach areas that are, let's say, composed of vulnerable communities. We want to make sure that those different communities are given a voice. So if you want to work closely with us, please do get in touch. And also, we aim to develop a next beach protocol in several different countries around the world in our next project. I don't know if Dr. Vito, who is there, can maybe share a couple words about which are the main cities that will be participating in our next beach cleanup protocol. Thank you again.
Of course, we will do, but we will not anticipate nothing for like the big end of this event. So there's with us also, I don't know, she's in the background, Paulino Witty. is in the background, Miro. Yeah, maybe we can let her join if you want. Hi, Pauline. Pauline Noviti was one of our, we can say, case studies collaborator. So I don't know if Pauline want to say a few words. In the meanwhile, we can just through this time, even though maybe. Hello, Pauline. I don't know if you hear us.
Hello.
Okay, so Pauline is here in COP. Actually, is like joining now the venue, and it's a pleasure to have collaborated with her. We like bring the you can say our study also like at the international level. I will show after the cities in which we act to apply the protocol and the possibility in which we want to apply the protocol further. But now let's go to another aspect of the data. So we have set the scene with Dr. Fernandez regarding the big problem of plastic pollution that's starting from the river, that then is affecting the shores and the sea, and to help like the monitoring, because we cannot manage what we cannot measure. Satellite data have like an important role. So we will start this topic with a video of our colleague Carol Maione, that unfortunately she cannot be here, and she sent us like her intervention. So now I will kindly ask to the mainstream to like show the video, please. Okay.
Today I'm going to present about satellite data for marine litter. So starting from the problem of plastic pollution. Plastic pollution is a global problem. There are some areas that are like also known as like garbage patch, and these are the area of most accumulation. But of course, the problem does not start there. Plastic pollution travels like from land into the ocean, across river, transported by wind and tide, and so on. So let's find out some of the way in which we can track this data in order to keep like this data more accountable and be able to finally like manage the plastic that is leaving the socio-technical system in order to go into the ocean. So when we talk about plastic pollution monitoring, of course, we mean like different level of analysis. We can have, for example, remote sensing, such as satellite technology. We operate on a larger scale. We have like field studies, such as like beach cleanups or like transit and so on, that can include different type of like from expert to volunteers. And finally, we can have sampling for more like smaller size plastic fragment. But how to choose between like the different methods? So we can have, in general, single method monitoring, which include just one of those categories that I just explained. We can have multi-method monitoring, which can include two or more single methods, such as field observation together with remote sensing. And finally, we can have integrated monitoring, which is what I'm going to discuss today. And that consists of a combination of different methods and instruments, including also qualitative and theoretical analysis for collecting data at different spatiotemporal scale. Starting from remote sensing techniques, the most common one are vessel-based aerial survey, aircraft-based aerial survey, submersible and remote operated vehicle, unmanned aerial vehicle and drones, optical satellite data, hyperspectral, multispectral, and finally SAR. And these are usually used to tackle debris size from macro to meso and sometimes even microplastics. Talking about macro level monitoring, some of the issues that we're trying to address when we use this type of technique are limited traceability, which is associated with different systems for marine and pollution monitoring and accounting, different policies that can allocate to allocate resources, lack of information exchange, especially across like border areas, and uneven use and communication of data analytics. In terms of what are the questions that we're trying to answer through this methodology, they're like what is the magnitude, location, temporal variability of plastic, the composition, the spatiotemporal distribution, and the abundance, and finally the physical mechanism that can influence the transport and accumulation of plastics. And some of the objectives through this study are like to provide real-time or nearly real-time data acquisition, wide area coverage, and high spatial resolution, and also to provide a consistent global harmonized system to assess plastic. But then, of course, we have a different level of analysis, which is the one of field study. And this usually includes techniques such as macro survey, direct observation, scuba diving, snorkeling, and manta which can also include citizen sign approaches and entanglement visual survey. And these are usually used for macro debris. When we use this level of analysis, the open issues that we're trying to address are the paucity of data on sources and amount of marine plastic pollution, and the uncertainty about the sources and pathways that the pollution is following in order to reach the ocean. Some of the questions we try to answer are: what are the areas where litter is most prevalent? How much litter? What is the litter composition and the principal type of materials? What are the principal items? What is the amount and how it varies across different transits? And what are possible variables that can affect the input of litter at sea? And some of the objectives of this type of study are to capture spatiotemporal variability of beach and coastal plastic pollution over time, and to provide a more accessible litter assessment using basic and cost-effective tools, which is why it is very popular across citizen science approaches. And finally, we have the lab scale. These include techniques such as sand sieving, sediment cores, trawling, bulk water sampling, and biota sampling. And this is usually used for plastic ranging from meso, but most likely for micro and nano scale. Some of the issues we try to address through this technique are the limited data on ecological and biological impact of plastic on native species, and uncertainty about the translocation across different trophic levels. Some of the questions we try to answer are concerning the abundance, distribution, and variability of microplastic, the incidence of encounter between microplastic and native species, for example, and how does plastic affect their subsistence. And in terms of objectives, we try to quantify smaller fragments, assess specific impact of plastic pollution, such as the incident of encounter, and the related effect, which can range from biological, ecological, changes in species feeding, and translocation. When we talk about integrated monitoring methodology, we try to address a different set of issues. Because, for example, we have some limitation related to the previous approaches that I just described. So, such as for in-situ survey, they need a tremendous human effort. They're very time-consuming. There is an inability to account for large diversity of land-based sources. They often fail to capture the movement and transboundary nature of plastic, and finally, they're not suitable for large spatial areas. When we talk about remote sensing, this can address some of the issues like explained for the in-situ survey, but on the other side, we have issues related to spatial resolution, limited temporal and spatial coverage, operational cost, and capacity. So trying to merge together and bridge the gaps from these two approaches, in this research, we want to suggest the use of multi-method approaches, which include decision-making on management and containment of transboundary plastic flows, detect possible loopholes in the plastic value chain, detect and assess the impact associated with the system outflows, and dislocated effect of plastic consumption, and finally guide policy and industrial recommendation. What are some of the advantages of integrated monitoring? They include supplying the current understanding, magnitude, distribution, and temporal variability of plastic pollution, their sources, fate, and pathways across the, and into the ocean, inform decision on how to sustainably manage material and pollution flows with a circular economy of plastic, and assess with management infrastructure in place and how the plastic got into the ocean in the first place, and implement priority action and transformative policy regarding waste management and industrial recommendation, and finally to detect a multifold impact of mismanaged plastic and trace them back to their sources. So what is the aim of integrated monitoring methodology? It is to identify a hotspot of plastic pollution, determine pollution sources, including both geographical and economic, and pathways and driving causes, and quantitatively estimate spatiotemporal variability of this flow. Some of the techniques that we can integrate into integrated monitoring include review to identify the hotspots, so the area where to start our analysis, a qualitative data collection, which can serve to confirm the previous finding and gather further information about the pollution hotspot. Moving on to the satellite remote sensing, which give us a uniform large coverage assessment of the identified hotspot over a long period of time. And finally, direct observation and field sampling, which is used as a ground truth information about the state of plastic at all locations identified through the previous approach. In terms of comparison of the different methods, we can say that as we have like only a few disk boxes taken for the single method monitoring, including the specific limitation of each of the most common methodology, and for multi-method monitoring, with the integrated monitoring, we can both provide information value, including spatial variability in areas of convergence of plastic pollution, temporal variability, quantification and characterization of this flow, and sources of and pathways of plastic pollution. But also we can provide decision support value, including the identification of loopholes across the entire like plastic chain and in the waste management system to identify the area from which the leakages start and like to go and tackle through like control measure, improving data collection and mismanaged plastic flow, which give us a more detailed understanding of what are like the main sources, the main items, the main plastic products found, and trying to address those specifically. The definition and priority to guide policy, and in order to direct this policy towards like the areas that are more that need to be prioritized and need more work on, and finally providing science-based industrial recommendation for managing plastic flows. So as you can see here, there's an example of how to integrate this for different level of analysis in order to identify what is called a hotspot of plastic pollution. So starting from the historical sources to identify if there's like presence of waste, mismanaged plastic, and the state of like waste management services on site. Moving on to a panel discussion, trying to understand the convergence of plastic pollution flow, and if there is an initial site that needs to be observed. Moving on to remote sensing observation, looking into the presence of visual anomalies, and especially if these are recurring over time. And once we identify this like pixel anomalies, we can move on to the in situ observation, try to understand what is the distribution of plastic in the areas that we identified through the satellite, and their spatial temporal variability, which can also require like repeated measurement. And finally, a slide that is like positive for all these steps, like become an identified like hotspot of plastic pollution. In terms of future research, what can be included into the steps can be like optical images collected along river segment to understand how much trash is flowing like from source into the ocean. Training data for plastic option detection using image classification, border detection, and so on, image classification algorithm, and data validation, of course, through in situ observation and field sampling to provide ground truth observation. Finally, some of the pillars that I'd like to address and why it's important to map marine litter through like satellite, through from the macro level into the micro level. They include, for example, education for ocean literacy awareness, the industry sector, such as like providing commercial application for monitoring technologies, technology for, of course, innovation, piloting, and funding, and finally, in terms of data, outcome-driven, and reporting progressive and audience. Thank you very much, and I'd like to leave the floor to my colleague for providing some best practices of how to track marine pollution.
So thank you, Carol, even remotely, and I will give directly the floor to Tim and Marco, probably to share some best practice and how to use data. So Tim, Marco, the floor is yours if you want to share your screen and go on your presentation.
Perfect. Thank you so much for having us. My name is Tim Perry. I'm one of the board members here at Clear Blue Sea. I'm here with our Director of Engineering, Marco Nunez Moctezuma, and we're here to talk to you guys about some of our approaches to remote monitoring and speak about some of the opportunities in the near future. So here at Clear Blue Sea, our mission is to cleanse our waterways and marine debris through remediation and education. We're a 501c3 nonprofit. We were founded back in 2016. We're down here in San Diego, California. Since 2016, we've worked with over 200 volunteers, focusing primarily on working with students and young professionals. We were founded by Susie Baer, who's a project manager with a decade of experience at NASA and another decade of experience at SAIC, and Jessica Gottdank, who is an engineer in the aerospace field. And we've been developing our floating robot for eliminating debris, or we like to call him Fred, which is an unmanned surface vessel. And originally the intention was to focus on cleanup, but the more we've learned about the ocean pollution problem, the more we've realized there's a huge need for data. And so we've really refocused to have Fred also be collecting environmental data as he's collecting debris. So here's a couple of the prototypes we've built over the years. Initially, we started out really small with a couple foot handmade prototypes left here. And then very quickly after that, we moved on to building some larger scale prototypes on top of some 16-foot sailing lines that we put some solar electric components on top of. And down in the bottom right, we have our Fred D, our DIY version. And the intention behind that is to release an open source package of this design so that interested in remote ocean could potentially build one of these and operate themselves. So our practices, being a bootstrap non, we've really focused on low cost iteration approach. So we've really focused on low cost source hardware and software to move really quickly and develop these programs very cheaply. So a couple of the components we've identified that have enabled that workflow is a Pixhawk with a drone flight controller, very common in the hobby industry. There's a piece of software that is open source called Boat, which can be loaded on, which is essentially USV control software already loaded. QGround, another open source piece, which is here on the right. And that's how you can give it the USV commands, waypoint. So you can give it a GPS waypoint, be able to navigate through a series of missions, and also have an operator remotely control the vessel. And then we also use pretty common low-cost data acquisition microcontrollers such as Raspberry or Arduino. And then we found a low-power, low-cost, long-range radio modem called the RFD 900 Plus. And so this kind of core package of hardware has really enabled us to move quickly. And the really nice thing about open software, already proven out by the host industry, is it cuts down on the software development time and also allows us to not have to worry about mechanical component test integration. It also reduces the risk of random errors from the software development. And the added benefit is there's a huge community behind these software and hardware devices. If you do have a question, it's very easy to find somebody who already solved that problem. And so to speak a little bit more about some of the best practices for selecting hardware for remote monitoring applications, I'll turn it over to our Director of Engineering, Marco Nunez.
How's it going, everyone? So one of the things that we gotta keep in mind when selecting hardware and sensors is they have to meet industry standards. In this case, we're looking more into the marine aspect, so it has to meet those same standards that vessels use. So for instance, they have to be rated IP67. That way they can endure the marine environment. Another thing we have to look at is because we're going to be drones, even in the air, in the water, it's something new to government entities. So we have to work with teams such as in the U.S. Coast Guard to apply AIS transponders so they can detect our vessels once we get to the large vessel phase. And in addition to that, there are a lot of areas, especially when it comes to doing research studies, that required permits to operate in those designated areas, such as in the Tijuana River National Estuary, which is here in San Diego, California, in between Mexico and the United States. And also, there's a lot of work to do with continuous improvement. So we got to do a lot of iterations. And with these iterations, we get a chance to involve the international community to give us some insight and to be able to provide us with their assistance in providing the best practices as possible. And a lot of documentation after documentation, because once a prototype is developed, we got to save that for legacy aspects and also in order to better our own processes and equipment. Next slide. And here, once we get these sensors, for instance, it allows us to be able to have them integrate into our systems due to its compatibility. Sorry about that. And also it allows us to combine it with module packages that can work with the different type of environments to get the data that particular people are interested in or there's a need for. And all, for instance, you can use these type of sensors in a package to be able to study marine life and a natural habitat without disrupting or disturbing the animals in that area. And also it allows us to track trash and marine debris and the flow and the distribution in that particular area. As you can see on the bottom picture, there's some photos of some sensors that we currently use. And on the right-hand side, you can see a list of different type of sensors that are currently used in the industry that we've worked with, or we will also like to work more with. Next slide. And then looking ahead, some of the things that we're currently doing as part of our best practices is one is reducing our USB scale. Another one is adding a ROS system, which is a robot operating system. Instead of using microcontrollers, we want to expand our ability to integrate more sensors into our own vessels, and also be able to, for instance, as you can see on the photo on the right, to be able to do that visual camera vision. In order to do that, you need bigger microcontrollers and also a larger data storage system. So that's one of just why we're moving also with NVIDIA Jetson Nano, and that allows us to capture this data, save it, collect it, and develop marine debris data sets. And also it allows us a chance to add more sensors into our own vessels, which allow us to do the modular sensor mounts that we're looking into. Thank you so much for the opportunity to be able to present to you all about our current product and state.
Thank you so much.
Thank you. Thank you. Oh, sorry.
Oh,
Thank you very
thank
much.
you.
Thank you to you guys, because you did an amazing job, and congratulations. Let's talk much also after this event, because I think that there is very great space for collaboration. So now I will close the session with my intervention. So I kindly ask if it's possible to share my slide. So we see different type of data, data from satellite, data from sensor, but also citizens can bring data and knowledge to our, we can say, resolution of the problem. So next slide, please. So I'm Domenico Vito. We already know each other during these days. I'm also a member of the Metabolism of Cities Living Lab. As a climate activist, I also have a background in bioinformatics and bioengineer, and also I deal with big data for SDGs, for One Health, and for climate change. Next slide, please. Probably talking about data, these are, of course, my colleagues that already intervened. Please, next slide. So the problem of plastic, we understand that is very huge. Just to give you some overall number, 8 million tons per year. So this is the amount of plastic that we are producing and is going into the sea. And we need properly to measure this to manage. But the current technologies can help to measure, but it's not the full story. But in fact, we can engage the citizens. So next slide, please. Okay, the next. Why citizen science? First of all, because it can have like a diffuse sensing of the data, but not only, because it can help to act on the source of the problem. In this case, creating awareness on the problem. If we engage citizens in collecting the data, of course, they are rendering the problem, the environmental problem, and also they are becoming more aware on for the next times, of course. And as I said, the use of communities can help also to have a more geographically wide areas. As we saw with Dr. Fernandez, we did the beach litter in Imperial, but also in Dunga Beach, and so on and so forth. Next slide, please. So, citizen science is not only important for getting data, but also important to getting the trust for policy making. Through the use of ICT, the use of, for example, the smartphone that now are available in a very diffuse way, it's possible to create bi-directional flows of information between the main stakeholder that deals with the interaction with the environment, that are, of course, the community, but also the decision maker and the stakeholder. And this exchange of information is also helping to empower all of these actors but also to like create trust, transparency, and accountability. And when we are trying to solve a problem, of course, we are like trying to implement a policy, for example, for plastic reduction. This exchange information is helping properly to make it more compliant. Next slide, please. Moreover, as I said, I'm an engineer and I like to like frame the problem with equation and things and so on. But of course, I cannot solve any equation without the border conditions. So without knowing which are the limits of my problem, which are like the constraint on the solution that we need to have. And on doing that, of course, the availability of like a wide geographically diffuse number of data can help to understand the problem. Going into the policy direction, basically the engagement of the community in citizen science can give the idea to the expert in the policy making properly in which is the, we can say, the real condition of like a photography of the concerned area. Next slide, please. So, what does imply citizen science, public participation, voluntary contribution, and knowledge production? Next slide, please. So, which is the main issue, of course, regarding the citizen science that need to be validated? The citizen science approach can produce a lot of data, a lot of like information, but we have also to select which one of that we need to share. But we actually have a lack of data. Just thinking about the SDGs, like the 78% of indicators related to the SDG framework have not sufficient data to be monitored constantly. And in this particular aspect, citizen science can have a great role. Next slide, please. So this is like a small comic to understand what citizen science can do. The scientists, of course, have their human limits to like get information, but citizens can help, can like support and rescue science into the like overall sea of information. So, as I said, for SDGs, citizen science is very important. This is a study from Direct Phrase and colleague that demonstrates that behind the normal source of information like satellite data, sensor, data banks, and so on, as we see before, another very important source of information for SDG monitoring is properly the engagement of the community through open science and citizen science approach. Next slide, please. And this is like the measure on how the citizen science can contribute. On this graph, you can see like the yellow, that is like the amount of increase in availability of information sending the SDGs for its custodian. The custodian are basically the agency of UN and also other agencies that are deputed to monitor globally the different SDGs. And as you can see, there are several that, of course, have already availability, the one in green, but also there are some that have not so much availability. And the yellow part is the increase of, we can say, potential in having information properly done by the citizen science approach. Next slide, please. Here, like I render information more on the SDG framework. Like the spots are the amount on how standing to each SDGs, the engagement of communities can help to increase the information about indicators related to each one of the SDGs. Next slide. And so that's why with the Metabolism of Cities Living Lab that is deputed to also work on localization of SDGs with the Leave No One Behind approach, we try to like implement some of these citizen science initiatives. My colleague, Dr. Fernandez, already showed some of the case studies. I will go very fast on that. El Astillero, Imperial, next slide, Dunga Beach. And here you can see like with the data that we collected with the community, we created some maps. Next slide, please. This is a case in Mediterranean. As I said, we are trying to apply this protocol worldwide, like extending. The Mediterranean is one of the most polluted sea. Unfortunately, we like here in Dubai and in all, we can say, the Middle East and the southern part of Europe, we very well know because it's a very touristic area. Next slide, please. But only we try to address the South Pacific. This is a case study that we performed in Venezuela. Next slide. And so with data, we are collecting and creating, first of all, visualization. That is the first way to express the information and to deliver, we can say, some concrete data, especially to the ones that then need to take decisions and so on and so forth. Here is a map that we built with like the data collected. And in red, you can see the spots where we found trash. And in blue, there are like the area limitations. So you can also measure you can say, the density of trash that you can find in a certain area. Next slide, please. And not only, my colleagues before show how in our beach litter initiative, we also invite the community to sort and to weigh the amount of waste that was collected in order to understand the stream flows and the metabolism of that area in terms of material flows and energy flows. Next slide. So why citizen science? Because it's raising awareness, first of all, because citizens are like engaged in seeing in reality the problem, because it can support science in its scientific activity, and can contribute to decision and policy making, because we can have a wider and more participative understanding on which is the problem. And so with the metabolism of cities, as my colleague Dr. Fernandez said, we developed this 7 and 10-step protocol regarding properly the data collection through citizen science for muddy litter and plastic pollution in the sea. Next slide. So to collect data, we rely on a very simple app that's called GeoPaparazzi that can allow to take photos and take the positioning in a very, very easy way. So every, you can say, volunteer, if he is not expert, can take some photo of the trash and can send us the position. Next slide, please. And this is like an example of the real application of our protocol in each one of the steps. So we ask it to collect, we ask it to sort, and we ask it also to analyze which type of waste it is in order to understand, as I said before, the material flows regarding that particular area. Next slide. So we are also building a database of all the case studies that we are collecting, probably because, next slide, please. We are trying also to develop and improve our protocol. Our colleague Carol Maglione has talked about microplastic and the problem of microplastic, because it's not just we can say the bottle on the shore, but this bottle is gonna we can say degrade. It's gonna create small fragments that are even more dangerous for our health. Next slide, please. And so today is a very important day. I also wear the shirt of Metabolism of Cities for this important moment, because we are going to launch the new campaign of From Trash to Treasure. This is how we can say call our initiative of beach litter and citizen science can say events. From trash to treasure, because we can transform what the others call trash in a treasures in terms of data, in terms of material that can be transformed in another way. And so we are collecting also interest for performing our beach litter all around the globe. Which best moment rather than COP to do that? So if you want to join us, you can scan the QR code and fill the form. So you can go to the next slide. Okay, and the idea is that after the launch, we will have like a roadmap to collect the data, but also to publish. We are scientists, we are researchers, and it's our duty to deliver, we can say, all the analysis and the research that we are doing with the data that we collect. So this is the plan for our campaign. So if you want to join, please, next slide. Fill the form, as I said, and join us in this amazing opportunity to work together for localizing SDGs, solve the plastic pollution, have like a more clean and like enjoyable sea. And thank you very much, everyone, for the attention, and looking forward for collaboration and engagement in this wonderful initiative. Thank you very much also to Digital Innovation Pavilion to hosting us and Mirrors of Poster, and thank you to all the speakers that has joined together in this important event. Thank you very much. Thank you. Okay. So thanks again to the speaker. Now we are closing the connection, and also to everyone that has joined us. Please follow up on our website and on our campaign. And thank you very much for that.